Hello everyone, welcome back to Benju's Education. So our today's topic of discussion is another video on data sufficiency, and in today's video we'll be discussing the concept of odd and even from the chapter numbers, right? So what we'll be doing is before jumping to the questions, I'll basically take you through the concepts of odd and even which you need to know. We'll just give it a quick revision so that you get again you can revise those things, you get again familiarized with the concepts of odd and even, right? And then we'll move on to the questions. Okay, right, so let's quickly go through the basics of odd and even. Now I'm assuming that you know what's an odd number, what's an even number. A number divisible by 2 is said to be even, and a number not divisible by 2 is said to be odd. So the general form of an even number is 2k, and a general form of an odd number is given to us as 2k plus minus 1. But again, k is an integer. Okay. Now, when you talk about even and odd numbers, uh, positive numbers are also even and odd, negative numbers are also even and odd. For example, if you say 2, minus 2, minus 4, 4, 6, minus 6, 8, minus 8, all these are even in nature. And if you talk about 1, minus 1, 3, minus 3, 5, minus 5, 7, minus 7, all these are odd in nature. Now, there is one discussion that is regarding the number 0. Now, remember that 0 is always even, right? Because according to the definition, if any number is divisible by 2, divisible by 2 means when you'll divide it by 2, in that case you'll get remainder is equal to 0, then the number is said to be even. So when you'll do 0 divided by 2, in that case your remainder will always be equal to 0, right? So the bifurcation of even and odd number is based on the fact whether the remainder is 0 or whether the remainder is 1. So 0 is also even, right? So now we know what are even numbers, what are odd numbers, and how do we represent them? What's the general form of representation? Okay. Apart from this, couple of other things which we need to know. First is we'll start with the sum. So that is if you do even plus even, that is always even. If you do even plus odd, that is always odd. If you do odd plus even, that is again odd. And if you do odd plus odd, that is again equal to even. It's some basic stuff, that's it. Second, if you have like n even numbers and if you add them up, the result is always even, whether n is odd or n is even. That is, let's suppose if you have 11 even numbers, add them up, the result is even. If you have 12 even numbers, add them up, the result is still even. So in either case, the result is always even. All right. Okay. When you talk about odd, so if you do odd one plus second odd number and so on and so forth, nth odd number, the result depends. The result now depends. It actually depends upon the value of n. So here we are going to have two cases. First is when n is odd. So let's suppose you have 5 odd numbers or 7 odd numbers or 13 odd numbers. So when n is odd, then the sum will always be odd. And if in case n is even, so you have like 8 odd numbers or 10 odd numbers or 16 odd numbers or 24 odd numbers. In that case, your sum is always even. In that case, your sum is always even. Okay. So this is regarding the sum which you need to know, just basic things, nothing else. All right, let's talk about product also. In case of product, remember this. If we want product of the numbers to be odd, if we want product of the numbers to be odd, then all the numbers needs to be odd. So if you're doing like odd 1 into odd 2 into odd 3 and so on and so forth into odd n, like the nth odd number, basically the result is odd. If you want product of numbers to be odd, then there is only one possibility, that is all the numbers have to be odd. If you want product to be even, if you want product to be even, you just need one number which is even. You just need one number which is even. Like for example, if you do odd 1 into odd 2 into odd 3 and so on and so forth up till odd n. And let's suppose you have like n odd numbers and you just had one even number, then also the result is even. So if you want product to be even, there are like several cases. You can have one number even, you can have two numbers even, you can have three numbers even, you can have all in numbers even. All of them are feasible. But if you want product to be odd, then there is only one possibility, that is all the n numbers should be odd. That's the concept. Okay. All right, let's talk about the powers or the exponent part. If you do odd to the power odd, result is always odd. If you do odd to the power even, then also result is odd. If you do even to the power odd, result is even. And if you do even to the power even, then also result is even. Okay. So these are like couple of things which we had to revise before we can actually move on to the questions part of data sufficiency. Okay, so these are like, this is like enough piece of information for you to solve today's question. Right? All right. Okay, then let's move on to the questions now. Let's see what we can do with them. So again, follow the same process. Pause the video, try the question yourself, because so that you understand where you're actually going wrong. Okay, pause the video and try this question, please. Okay. So PQR are three distinct positive integers. Find the even odd nature of this expression. We're basically looking for a conclusive answer, whether this expression is conclusively odd or whether this expression is conclusively even. PQR are three distinct positive integers. Okay, so PQR are positive integers and P is not equal to Q, which in turn is not equal to R. This is the information given to us. We need to find the even odd nature of P to the power 7 minus Q to the power 4 plus R to the power 16. Now, it would actually depend upon the even odd nature would actually depend upon the values of PQR, not in fact values, the nature, whether P is odd or even. Similarly, whether Q is odd or even, or whether R is odd or even. So I need to figure out the nature for all three of them. Then only I can say something. All right. The first statement says that P plus Q plus R is even. Now, if I want the sum of three numbers to be even, case number one is PQR all have to be even. And case number two is two of them are odd and remaining one is even. Two of them are odd and the remaining one is even. And when you talk about the first part, that is PQR, all three are even. Okay. Now, let's solve for both of them. If PQR all three are even, so I'll do even to the power 7 minus even to the power 4 plus even, I'll write this as even to the power 16. Now, even raised to any power will always give you result as even. So this will also be even, and the third one will also be even. Even plus even is even, and even minus even will also be even. So if all three of them are even, then I think that there is no point of having any discussion. We know that the result will be even, that's for sure. Okay, we know that the result will be. So from the first part, I can say that even is my conclusive result. Okay, what about the B part? Two are odd and the remaining one is even. Now, whichever two are odd, again, it's about the power. Whichever two are odd, we know that odd number raised to any power will give us the result as odd. We just discussed this couple of minutes ago. Odd number raised to any power will always give you odd, and even number raised to any power will always give you result as even. Now, so if we talk about P to the power 7 minus Q to the power 4 plus R to the power 16. So what all possibilities can I have? It may happen that P and Q are odd. So in that case, this will become odd minus odd. And R will automatically be even. So this will become plus even. Another possibility is P and R are odd. So this will become odd. This will become odd and Q is even. So this becomes even. Or I can have Q and R is odd. So this is odd. This is also odd and P will become even. Now, whether you add two odds, whether you add two odd numbers or whether you subtract two odd numbers, whether you add two odd numbers or whether you subtract two odd numbers, the result is always even. Which means this will give you result as even. Which means odd and odd here will also give you result as even. Which means this two odds will also give you result as even. Now in all the three cases, either you are adding even to even or you're subtracting even from even. So what will be the result? The result will again be even. So from the first statement that I have, I'm able to figure out two cases, and both the cases are giving me a conclusive answer, that is the nature of p to the power 7 q to the power 4, sorry, minus q to the power 4 plus r to the power 16 is even. So if I say D A B C E, B goes out, C goes out, E goes out. Either statement 1 alone is sufficient, which means A is the answer, or both the statements individually are sufficient, which means D is the answer. Let's look at the second one. Now, second one says that P into R is odd, which means P is odd and R is also odd. I just told you that if you want product to be odd, then all the numbers have to be odd. Now, if P is odd, then that means P raised to the any power will always be odd. Q is odd, that means odd raised to the power any number will always be odd. Now, even if I add these two, this will give me result as even. So I will have an even number minus q to the power 4. Now, do I know the value of q? Do I know the value of q? No, I do not know the value of q. Q can be odd, q can be even also. Q can be odd, q can be even also. If q is even, then this will become even minus even. If q is odd, then this will become even minus odd. So do I have a conclusive answer? No, I don't have a conclusive answer from statement B alone, which means D goes out, and hence your answer is option number A. Hence your answer is option number A. Okay. Now let's move on to the second question. Pause the video and draw this question, please. Okay, again, what's the even odd nature of 3p minus 6q plus 7r? Okay. Okay, now before we actually move on to the statements, there is something I would want you to observe and understand. I have 3p minus 6q plus 7r. Okay. If I look at this, there is one thing I can confirm, and that is the value of 6q, this will always be even. Because q is multiplied by an even number, 6 is an even number. Even number multiplied either by even or by odd will always fetch you an even result. So no matter what happens, 6q will always give you an even result, that's for sure. Which means the actual question is only about one thing, that is, can you figure out the nature of 3p plus 7r? Can you figure out the nature of 3p plus 7r? That's the only goal that we have. Because 6q will be even. Whether you can figure out something about q or no, it doesn't really actually matter. Okay, 6q will be even. Alright. Now, what does the two statements say? The first statement says that p plus r is even, which leaves us with only two options. Option 1 is both of them are even. Option 2 is both of them are odd. Option 1 is both of them are even. Option 2 is both of them are odd. Now, if I take case number 1, that is when both of them are even, this will become 3 into even plus 7 into even. Now, 3 into even will be even, 7 into even will be even, and so this will give us even plus even, which is effectively equal to even. So, the nature of 3p plus r, 3p plus 7r, my bad, is even. And 6q being even, so this will simply become even minus even, because we have a negative sign in front of 6q, so that will simply be equal to even, and that's it. That's your result. That's it, and this is simply a result. That's it. Now, the B part of this statement 1, when both of them are odd, so you will have 3 into odd plus 7 into odd. So this is odd plus odd, which is simply equal to even. Now, so this will give us result even minus even, because 6q is also even and this is also even. So whether P and R are both even or whether P and R are both odd, from statement 1 I can definitely conclude that 3P minus 6Q plus 7R is even. 3P minus 6Q plus 7R is even. Okay, so if I say D, A, B, C, E, so B, C and D again goes out. Either it's statement 1 alone sufficient, which means A is the answer, or both the statements are individually sufficient, which means 2 is the answer. Okay. Second says that P is less than Q, which is less than R, and P, Q and R are distinct integers. So this actually leaves me with like a lot of possibilities, right? It's not given to us that P, Q and R are like consecutive integers. Like what I mean to say, it's not given to us that P, Q and R are numbers like 4, 3 and 2. It's just given to me that they are distinct, where P is less than Q, which is less than R, which means you can have P as like 4, Q as 10, this as 14. You can also have this as 4, this as 9, this as 13. Or you can have this as 4, this as 9, this as 14. There are like a lot of possibilities which can happen. It's just given to me that P is less than Q, which is less than R, that's it. So don't confuse this for the fact that the three numbers are like consecutive integers. Don't confuse it with that. Otherwise, you'll end up getting the wrong result. Okay. So let's quickly remove this. Now we have understood what this statement means, which means that P and P can be even, P can be odd, Q can be even, Q can be odd, and R can be even and R can be odd. All of them are possible. So now I don't need Q because I know that 6Q will be even irrespective of the fact whether Q is odd or even. It does really doesn't matter. But with P and R, we have four different possibilities. We can have P and let's say R. So this can be even, this can be even, this can be even, this can be odd. P can be odd, R can be even. P can be odd, R can also be odd. All four are there. So let's talk about 3P plus 7R. 3P plus 7R. Now, if R and P are both even, then 3 into P, which is even, will give you even, and 7 into R will always be even. So this will simply give me result as even, that's for sure. Second case, when P is even, R is odd. When P is even, 3P will become even. When R is odd, then 7R will become odd. Even plus odd is odd, so this will become odd. Third case, P is odd, 3 into odd is odd. R is even, 7 into even is even. So odd plus even is also odd. Last is P is odd, R is also odd. So 3 into odd is odd and 7 into odd is again odd. The odd plus odd is even. So if we talk about the value of 3P plus 7R, if we just talk about the value of 3P plus or the nature of 3P plus 7R, this can be odd, this can be even also. This can be odd, this can be even also. So do I have any specific relationship for 3P plus 7R? Do I have a specific nature for 3P plus 7R? No. It can be odd, it can be even. So unless and until I have a specific nature for 3P plus 7R, I can't conclude anything regarding 3P minus 6Q plus 7R. Right? That's not feasible for me. So statement 2 alone is not sufficient, which means again my answer becomes A. Again my answer becomes A. Alright, let's draw the third question now. Okay, pause the video and try this question, please. All right, let's try this one now. X and Y are positive integers. Okay, X and Y are positive integers. X is odd. X is odd. Is the product of XY even? I think there should not be one more is here. This is grammatically incorrect. Excuse me for this. Is the product of XY even? X and Y are positive integers and X is odd. Is the product of XY even? Okay. Okay. First statement that I have. Okay. If first of all, before I want, if I want the XY even, then either both X and Y even. This will give me a conclusive answer, or one of them even will also give me a conclusive answer, or both odd will also give me a conclusive answer, or both odd will also give me a conclusive answer. Now it's given to me that X is odd. It's given to me that X is odd, right? So X is already given to me that X is odd. So I just need to figure out the nature of Y. This is the only thing that I have to do. Now whatever nature it comes out to be, I will have a conclusive answer, because the question is the product even? So if I have a conclusive nature of Y as even, then I'll say yes, the product is even. If I have a conclusive nature of Y as odd, then I'll say no, the product is not even. So either way, you will get a conclusive answer. I just need a conclusive nature of Y. I just need a conclusive nature of Y. Let's try that. First statement says that x cube y is equal to 6a cube plus 23. Okay. And it's given to me that a is a positive integer. The only thing that's given to me that a is a positive integer. Now a can have two possibilities. A can be odd, a can be even. But would it actually matter? As far as the nature is concerned, would it actually matter? No. Because a cube is being multiplied by 6, which will automatically make it even. So 6a cube will definitely be even. 6a cube will definitely be even. And on that even, you're adding 23. On that even, you're adding 23, which means the overall result will automatically become odd. So you have x cube y, which is automatically equal to odd. Which is automatically equal to odd. Okay. Now still we are unable to figure out a conclusive nature of y. Now x is odd. This is given to me in the question. X is odd. If x is odd, then I can also say that x cube will be odd. Odd. What is x cube? X cube is x into x into x. That is like odd into odd into odd. So that will also give me odd. So odd multiplied by y is equal to odd. Now at the beginning of the video, I told you that if you want product to be odd, that will only happen in one case, and that is when all the numbers are odd. Which means I have a conclusive nature of y. I have a conclusive nature of y, that is y has to be odd. That is y has to be odd. So from statement 1, I have a conclusive nature of y, and that is it is odd. X is already odd, and we have figured out y to be odd. So what is odd into odd? That is still odd. So is xy even? Conclusive answer is no, xy is not even. Right? So we have a conclusive result, that is xy is not even. Right? We are looking for a conclusive result, not an affirmative one. You write D, A, B, C, E. So B goes out, C goes out, E goes out. Either D is the answer or A is the answer. And let's look at statement number 2. X square plus y is equal to 3k plus 7. Now again, k is a positive integer. Again, k is a positive integer. K can be odd, k can be even. Now in this case, it matters what's the nature of k. Because 3 into k may be even, may be odd, we do not know that. So let's take first case. When k is odd, so you will have x square plus y is equal to odd plus odd, which will give you x square plus y is equal to even. Now x is odd, which means its square will automatically be odd. So odd plus y is equal to even, and that can only happen when y is odd. That can only happen when y is odd. Now this is only the first case. This is only the first case. Okay, now let's look at the second case. Now I'll take k to be even. If k is even, then 3k will automatically become even. And adding 7 to that will automatically become odd. Because even plus odd is how much? Odd. Which means x square plus y will automatically be odd. Now x square is odd. So odd plus y is equal to odd. And that will only happen when y is even. That will only happen when y is even. So from statement 2, I have both the conclusion, that is y is odd as well as even. So do I have a conclusive result as far as the nature of y is concerned from the second statement? No, I don't have that. Which means second goes out, which means D goes out, hence A is again the correct answer. Alright, let's move on now. I hope this question is clear to everyone. Pause the video and try this question, please. Alright, let's try this one again. X and Y are non-negative integers. Okay, so these are like non-negative integers. What are non-negative integers? Non-negative integers are 0, 1, 2, 3, and so on and so on. Okay. So x and y can be like 0, 1, 2, 3, 4, 5, 6, whichever one you want to take. It's like positive and 0 apart from that. Is this even? This is the actual question. Is this even? Now observe. See, again the first thing is observe. You have 4x to the power 4. Now whether I take x to be odd or whether I take x to be even, whether I take x to be odd or x to be even, they're getting multiplied by 4. They're getting multiplied by 4. So 4 is an even number, which means no matter what the nature of x to the power 4 is, no matter what the nature of x to the power 4 is, the nature of 4x to the power 4 will always be. The nature of 4x to the power 4 will always be even. Even if you take x to be 0, 0 to the power 4 is 0, 4 into 0 is again 0. And that will again be even. Right? So irrespective of the value of x, one thing is sure, that 4x to the power 4 is even. Which means if I talk about 4x to the power 4 plus 3y to be even, if this is even, for sure, that means I just need the nature of 3y, which actually means I just need nature of y. So again the question is, find the nature of y. So I don't even have to look for nature of x, because that's not going to help me at all. Which means if I read the two statements, just by looking at the two statements I can say that I don't need one, because the statement 1 has nothing to do with y. It's only about that x cube is odd, so that is x is odd. And whether x is odd or even, 4x to the power 4 will always be even. So statement 1 is technically, it's redundant for me. So if I talk about D, A, B, C, E, I can simply cancel A and D. That is, statement 1 alone is not sufficient, which means both these statements alone are not sufficient, hence D is also out. So either it will be B or it will be E. I won't even go for C because it can't be. X cube does not give me any information. X cube does not give me any information regarding Y. Okay. Now, I think I've said one thing incorrect. It can be C because if Y is somehow related to X in the second statement, if Y is somehow related to X in the second statement, and that may lead to whether Y is odd or even. Okay. But one thing is sure that A and D is out. Okay. Let's keep aside everything else. Forget about B, C, and E. But A and D are definitely out. Now, second statement says that y to the power 2x plus 3 is even, which means y to the power 2x is equal to even minus 3, which means y to the power 2x is equal to odd, which means y to the power even is equal to odd. A number raised to its even power is odd. A number raised to its even power is odd. Can I say there is only one possibility, that is y has to be odd? Neither can y be 0 because 0 raised to the any power will automatically be 1. Sorry, my bad, it will be 0. My bad, it will be 0. It can't be an even number because even raised to the power even will always be even. So the only possibility that I have, if I want to satisfy this, that is y has to be odd. That is y has to be odd. So if y is definitely odd from statement number 2, then that means here y is odd, which means 3y is odd, which means 4x to the power 4, which is even, plus 3y, which is odd. The sum will automatically be odd. So is the sum of this expression even? The conclusive answer is no. The conclusive answer is no. No, the sum is not even. The sum is odd, but we have a conclusive answer. That's the whole point. Hence, in this case, the answer becomes B. I think this was a simple question of all the questions we have solved till now. So I think this was fairly doable. All right, let's try one more for this video. Pause the video and try this question. All right, let's try this one. This seems a bit difficult. P and Q are integer and P is greater than 0. So P should be something like 1, 2, 3, 4, 5, and so on and so forth. And there is nothing mentioned regarding Q. So Q will be like minus 3, minus 2, minus 1, 0, 1, 2, 3, and so on and so forth. So Q can be 0, Q can be negative, Q can be positive. Also, is Q an even number? Is Q an even number? Okay, this is what we need to figure out. Let's see what we can do. Okay, so first statement is P plus Q into Q minus P is even. P plus Q into Q minus P is even. Okay. Now, if P plus Q into Q minus P is even, so what all possibilities do I have? One is both of them are even. P plus Q is even, Q plus P is odd. Or P plus Q is odd and Q minus P is even. These are the three possibilities that I can have. Now, let's see which of them actually satisfies also. Let's first talk about these two properties because I know that even property will definitely satisfy. I'm not sure about these two. That is when P plus Q is even, Q minus P is odd. So let's check the first one when P plus Q is even and Q minus P is odd. If I add the two equations, P and minus P will get cancelled. I will have 2Q is equal to even plus odd, which is odd. So this will give me Q is equal to odd by 2. Now, is it possible for you to have Q as odd by 2 where it is given to you that P and Q are integers? Is it possible for us to have Q as odd by 2 where P and Q are integers? No, it's not possible. It is definitely not possible because odd by 2 will be a decent value like 0.5. So the second and third condition will not satisfy. The only condition which will satisfy when both are even. When they both are even. Okay. So P plus Q is even and Q minus P is even. So we have P plus Q as even and we have Q minus P also as even. So what all possibilities we can have in this? Okay, this is definitely going to be a long one. So P plus Q is even, which means both of them are even or both of them are odd. Similarly, if you have Q minus P as even, that is again both of them are even or both of them are odd. All right. Okay, so is there any condition which actually doesn't satisfy? No, I don't think so. I think both conditions will satisfy. Right, both conditions will satisfy. Whether you take positive numbers or negative numbers, I don't think it should actually matter. So if you take both of them to be even, then also my product should be even. If you take P and Q both to be odd, then also my product will be even. So actually I don't have to worry about this. So I don't think I'm getting any conclusive result because P and Q can both be even, can be odd also. All right. So D, A, B, C, E, which means A goes out, D goes out. Statement A alone is not sufficient. Now, in this case, also remember that when I'm talking about Q to be even, Q can be 0 also because I just told you that 0 is an even number. Right? At the starting of the video, I told you that 0 is an even number. So Q can be 0, Q can be other odd numbers or even numbers, but yeah, P can be even at the same time Q will be even. P is odd at the same time Q will also be odd, that's for sure, and Q can be 0 also. So basically from first statement I'm not getting anything. I don't have anything conclusive. Okay, let's look at the second statement. P to the power Q plus Q to the power P is odd. I want product to be odd, which means this becomes even, this becomes odd, or this becomes odd and this becomes even. Again, these are the two possibilities that I have. Okay, so if P to the power Q is even, let me write uh, this part here. If P to the power Q is even, then P has to be even. But when you talk about Q, Q can be even, Q can be odd. Similarly, if Q to the power P, because this is the odd condition is also something which I need to satisfy. If Q to the power P is odd, then Q has to be odd and P can be even as well as odd. P can be even as well as odd. Both of them P can have. But I have to satisfy both the conditions simultaneously. Right? I have to satisfy both the conditions simultaneously. Which means if I want P to the power Q to be even and Q to the power P to be odd, so P is even, which means it can't be odd. Q is odd, which means it can't be even. So P is even and Q is odd. Okay, this is the conclusion. If I go for the second one, of course I will have the vice versa, that is the opposite part. That is P will automatically become odd and Q will automatically become even. I will have exactly the vice versa. Okay, so I have P even, Q odd, I have P odd, Q as even, that is the opposite. Now what if I combine both of them? Now here is the catch in the equation. Here is the catch in the equation. Let's see what that catch is. The catch here is that if you look at the conclusions from statement 1 and 2, now one thing is I don't again have a conclusive answer that whether this Q is an even number or no, so B also goes out. So B also goes out. Now here is a catch in this question. If I combine both these statements, you'll be like, okay, from the first statement I'm getting both of them to be even or both of them to be odd. From the second statement, I'm getting P to be even and Q to be odd, or P to be odd and Q to be even. That is the exactly the opposite of each other. One even, the other odd. You'll be like, okay, I don't think I have any, I don't think I have anything in common. So I don't think there's any point of combining them. Now you are right, but you're actually missing out one case in this, the case of zero. What about when Q is zero? What about when Q is zero? Because Q is equal to zero is actually a very important case. So if I take Q to be zero, if I take Q to be 0, then from the first statement, I would want minus P square to be even. Because when Q is 0, then it will become P plus 0 into 0 minus P. That's minus P square, which is even. And that will only happen when P is even. That will only happen when P is even. And if I put Q is equal to 0 in the second one, if I put Q is equal to 0 in the second one, so this will be an integer raised to the power 0 plus 0 raised to the power of positive integer, because it's given that P is greater than 0. P raised to the power 0 is 1. 0 raised to the power P is 0. So this will again give you 1, which is effectively odd. Which is effectively odd. This is the only case which is satisfying both the conditions. This is the only case when it is satisfying both the conditions. Now, you may say, okay, we have P even, so you can keep P as even. There's no problem. You can also keep P as even here also. This is also true. 0 raised to an even power is 0. Even raised to the power 0 is 1. So 0 is actually the case for which you need to think about this. So actually the answer is not E. The correct answer is option number C. Correct answer is option number C. Alright, so I think I have given you I think you have understood like how do you approach questions based on odd and even natures of number system. Alright. In another video we'll talk about a couple of more questions related to number system. Right. So as far as this video is concerned, this will be all. So thank you so much guys for watching the video. If you have any questions, if you have any concerns, you can always let us know. You can WhatsApp us, you can Telegram us, you can drop us a mail, or you can also drop in a text on the chat box on YouTube also, right? And don't forget to subscribe the channel for more videos and exam related content on SAT, GMAT and GRE, right? If you're looking for personalized classes, you can always connect with us on the given numbers, right? Alright then guys, thank you so much. Keep watching and keep learning.